Okay, we have here to take another integral from the UNSW CPMS integration bee from 2023. This was round 2, problem 2. We have the integral of 2 cosine squared x over cosine x plus 1 dx. Okay, my first time doing this, I actually did it using a half angle substitution, and it was a pretty long process. It was kind of messy, and then in the end, my answer didn't really look like the UNSW solution. It's probably the same thing, but it didn't look the same. And then when I looked at the UNSW solution of this, I realized there might be a much easier way. The thing that's interesting with this is just the fact that we have a higher degree in the numerator than the denominator. We've got cosine squared there, and we just have cosine to the first power here. And so what I found helpful with this was actually to look at it like, what if we had an integral, like let's say we had 2x squared over x plus 1. Well, for this, there's kind of a standard way to handle it. When we have the degree is equal or greater in the numerator to the denominator, we do polynomial long division, or we can do some kind of simplification on the fly with the algebra. So what I want to do with this problem then is basically the same thing. I want to do like polynomial long division or some kind of simplification so we can get rid of this cosine squared here. So the way I can do that is by rewriting this and trying to get some cancellation. So what I want to do is, instead of doing the polynomial long division, I want to try to create a cosine x plus 1 so we can cancel something out. So we're starting with 2 cosine squared x here. In order to create this cosine x plus 1, what if I just add 2 cosine x here? Because doing it this way, if I factor a 2 cosine x out here, then what we're left with is this is just going to become 2 cosine x times cosine x plus 1, and that's going to be our cancellation. But now, of course, I don't want to change it, so we'll subtract off this 2 cosine x, so I'm actually just adding 0. And then what I can do is break this into 2 separate integrals. So for this first one, we'll split it up with this factorization here. I'll write this as 2 cosine x times cosine x plus 1 all over cosine x plus 1. And for the second one, I'll bring the minus out front, I think, and then we'll have here 2 cosine x over cosine x plus 1. But then here, the cosine x plus 1s are going to cancel out. So then this becomes a simple integral, just 2 cosine x. But now with this integral here, we're kind of back in the same situation we were here, where we kind of want to reduce this, or we need to do something in order to make a u substitution. Well, what I can do is, if I just actually add a 2 here, well then, now we can do the same thing again, where if I factor a 2 out, we've created cosine x plus 1. But again, I don't want to change it, so I'll subtract off this 2, so we're just adding 0. So then coming back here, we'll just integrate this one. Integral of cosine x is just sine x, so for this first piece, we get 2 sine x. Then here for this integral, what I'll do is we'll use this factorization we did right here, and we'll write it as 2 times cosine x plus 1 all over cosine x plus 1. But then for this minus 2, I'll split this into a separate integral, but we'll have minus times minus gives me plus. I'll bring the 2 out front, and this last integral is just going to be dx over cosine x plus 1. But then again, we get cancellation here, so we're just integrating 2. That's pretty nice. And then we're still going to need to do this integral here, but at least we cleaned out our numerator, so this shouldn't be too bad. Okay, now from here, let's just deal with this integral now. So one thing we get to here is half angle substitution and go through that. But I think what I want to do is something similar, but what I'm going to do is, let's look at this identity for the half angle formula for cosine x over 2. The formula for this is just plus or minus square root of 1/2 cosine x plus 1. And the reason I'm doing that is because what we have here in the denominator, that's exactly what we have here. So I just need to isolate this. And what I can do is, we can square both sides here. So if I rewrite this, if we look at cosine squared x over 2, plus or minus isn't going to matter because we square it, so that goes away. Squaring it, we also get rid of the square root. And we don't have to worry about absolute value here because cosine x is never less than minus 1. So this is always positive. So what we have on the right side is going to be just 1/2 cosine x plus 1. But then to get this alone, what we can do is multiply by 2 on both sides. This is going to cancel with this, and now we've got an expression for cosine x plus 1. So now coming back to our integral over here, what I want to do is we have this value for cosine x plus 1. I just want to plug in this value, 2 cosine squared x over 2. So rewriting this, we'll have our 2 out front, dx, and then plugging this in, we're going to have 2 cosine squared x over 2. But then I can cancel the 2's here. And then because we have cosine squared in the denominator, I can rewrite this as secant squared x over 2 dx. But secant squared, that's a really well-known integral. That's just going to be tangent x over 2. But I just need to remember this 1/2 here and bring it out. And the reciprocal, so we'll bring a 2 in front. And so this will be our value for this last integral here. So now in order to finish it, all I need to do is integrate 2, but I think in my final solution, since notice we have a 2 and everything, I'm going to actually factor a 2 out front of the whole thing, and then we're just integrating 1 here. So for my final solution, we'll have 2 times sine x. This is just going to become minus x, and then here we're going to have plus tan x over 2, parentheses, plus c, and that's it. Okay, there you have it. Good problem from UNSW CPMS 2023. Thanks everyone for watching. Have a good day.